Alright guys, welcome back. In this video I will go over what I've done here just so that you can get a better understanding of a few things. I'll talk a little bit about collision, a little bit about the setup that I've done, and like in this case because we're going to be using the local co-op instead of, because you might run into this issue yourself if you're making local co-op. And I'm simply just going to show you what I've done here as well as prepare you for the next video, which is the animation bits. We're going to talk about animation and another setup, of course, but for now, let's just start with the basics. If I play the game right now, you will see that I have two pawns, one on the left, one on the right. They're both controllable by separate keys. So the one on the right side is controlled by, by the arrow keys, and the one on the left side is controlled by the WASD. Well, with the exception of S, although we could definitely add that later as well, such as instant landing, some like special skill. But for now, we only have like a W like up, which allows us to jump, and of course we can double jump if we want with a equally weird spin. Right now we're spinning towards the net, but of course it is a modifiable spin, and there's always also a window in which you get to press the spin. So if the spin is not available, obviously some of the adjustments are not complete because I do a lot in the actual blueprint itself. In other words, in this case, of course, there's a delay until you get the secondary jump enabled, and the whole system runs on a delay, which is currently 1 second. So you can't actually double jump that often. But that being said, of course, everything is adjustable, so it doesn't really matter. This is simply the functionality in the framework that we need to set this up. Second, of course, we have the ball itself, which only is being set to be moving at a kind of flew out. In the one axis, so it's simply one-dimensional, only the X and the Y. Of course, this is not the behavior that we want for it to fly off, but that's a secondary concern for now. We simply want to have the control set. Of course, this is probably also not a desirable angle for our, for our shadow. And as you can see, I think the LODs are kicking in because the shadow is kind of fucked over the further it is from the camera. That being said, we have a very simple collision system here, which we will change later when we go over the animation system entirely. As you can see, currently I have these spheres which act as collision for my mesh, which is the worm itself. And if I just move this, by the way, here is where you make constraints into physics, right? You enable your physics, you simulate them. And then, of course, you lock the position, the rotation. You can choose a particular different mode. For example, to lock it to the YZ plane, which is what we need. We want to walk only here. We don't want it to be bouncing off, on the sides, because our players will only be able to move from left to right. But I've, decided to just do this myself. Now, that being said, if we play this, I want you to take a closer look here. If I simply just look at the way the ball bounces, right? It just goes up and down. It doesn't make a lot of sense in the way it behaves, and that is because our collision is actually fairly primitive. Now, generally speaking, this is exactly what you want. You don't want your characters to be having super precise collision because that's expensive stuff. Now, in our case, of course, we'll modify this to be a lot more precise. And because we have only 2 players, and really there isn't a lot of stuff happening on the screen, this is not going to be an issue. And precision is kind of what we need, since the gameplay is pretty much dependent on the way you're going to hit the ball. That being said, let's just run over some blueprints. If you remember, we have them set up like this. We had the levels folder, which is a bunch of levels, and then we got the blueprints. Now, I didn't color code these. I usually do, but in this case it's just pointless because I will just run through them really quick. We've got the gravity component, as you may remember from the previous video where I showed you the movement component, like different ways of generating movement. I've simply created a gravity component in this case, very primitive. You just get the owner cast to the pawn, which is the owner presumably, and then every tick you simply, if gravity is enabled, you add a movement input downwards. Facing downwards with the gravity amount of minus 9.80665. And you force it down, right? It doesn't matter if it has input or doesn't have input. It will always have to be down whether input is enabled or disabled. This is just a precaution, of course. We will not be disabling input by default. Now, that being said, that's the gravity component. Now we can go into the game logic. Now, the game mode itself, I believe, is empty right now. Yeah, there's really nothing here. But the worm controller in the worm HUD, worm HUD by the way, I believe is also empty. Yes, it is. But the worm controller is not. There's definitely the logic for movement. The reason I decided to do this in worm controller, of course, is because I wanted to showcase, simply use the same logic over and over. For more than one player, like whenever you have local play, you do have a little bit of a problem because your controller, right? So one player controller can only have like this. For example, this function, right? Get player controller. Well, we are currently in the controller, so if I open, let's say, the game mode, and I just open the blueprint editor and I say get player controller, as you can see, we get the player controller and get the player index. Now the problem is that player with the index 0 is of course us, and a player controller can only use one control. So in this case, we can only use the keyboard. And because of that, we cannot actually define a second player to use a second player controller using the same keyboard. You could say, yeah, it'll use a joystick, but that means that your game will only be playable from a joystick, okay? If you want to have local play, you need to have the other player use a joystick, and then it's just fine. But when it comes to completely local, when it comes to only one device, single device, then in this case, you're kind of screwed because, well, let's face it, you only have one controller for that. That being said, I simply just want to delete this. I'm going to close the game mode and we'll go over the logic again. First and foremost, I usually just cache a bunch of stuffs. In this case, these are references for player 1 and player 2 players, player characters such as the worm. I'm simply getting them since I had some problems with the get player controller here. Get the player pawn. For some reason, I only got the first worm. I could not get the second one to cast, so I simply used get actors of class. Again, this is not standard procedure because the idea is other players will be actually connecting from multiplayer standpoint, right? So you need other controllers. In this case, we don't, so we're going to have to run the way it is. Now, I've also created separate inputs. If I go to project settings, you will see in the input mode here is that I have player 1 jump and player 2 jump when it comes to the action mappings, and same goes for axis mappings. So these mappings here, obviously we might include like an option to change them, but they're pretty standard, right? WSD to move and left and right to move for the player 2. Also, of course, I've reversed the scales so that, the left on one side is, sorry, I didn't reverse the scales, so they're the same, but, you just get the idea of how this is going to operate. And as you can see, I'm firing them off here. The green bits are everything that's related to player 1, and the blue bits are everything that's related to player 2. There we go. We have action input P2 jump, P2 left right, and the same goes here. P2 jump, P1 jump, and P1 left right. With that being said, really there isn't much difference from the way I implemented this from the previous video, so you might as well just go and watch that. There are a couple of things that I changed up. For example, I'm selecting a float here. I don't have like a separate function to set it. Double jump, everything is pretty much the same, all right? So there's really no difference. The only actual difference is that I have a lot of curves, which are external here, allowing me to, to control every aspect of the, the actual control input. So currently everything is linear, and that's why it just looks so weird, right? As you can see, my jump doesn't have the snap to it, and my double jump definitely doesn't. Like it does look all right, but the spin is kind of lame. And of course, we have no animations, which we'll add next in the next video. However, there's one more thing we need to talk about, and that is the way collision is formed. Because I'm applying the gravity component over here. If I open my player 1, for example, as you can see, I have a gravity component, which of course, and a floating pawn movement, of course, which is constantly adding my gravity, which is just going downwards in acceleration. Currently, the way I'm controlling this is simply adding the input vectors. I'm doing all the math in the worm controller. Of course, I could have just as easily done that in this object here, because presumably it's not going to get destroyed. But I generally like to have my stuff in the worm controller, because if I have to use it for something else or change the pawns out, it's not going to break. That being said, of course, the pawn controller itself is not the best possible setup. You really it's not a really good idea to have repeating logic like this, because you can imagine if I have 4 more players or 2 more players, I might have to do this 2 more times. Ideally, you might want to inherit this, or really the best situation would be to have an interface, and every player character, every worm would be playable. So they would have, each worm would have a respective jump for it. All right, so you'd have like toggle jump, double jump. But then again, the problem arises from having only 1 player. Now there is one thing when it comes to local co-op here, and that is over here at the bottom. It's not here. No, there it is. No, it isn't. Let me just search for this thing. Split screen. When it comes to split screen, there we go. It's local multiplayer, so it's in multiplayer, I believe. Oh, project maps and modes. All right, there it is. At the bottom here, local multiplayer. It says use split screen. That is, of course, when we have local multiplayer, and really there's no need to use a split screen in our case, because again, we're not going to be splitting the screen. We're in constant view of the screen. So that's the way I approach this. Probably there's something you could do with this. So you could have like something with gamepads, and other players will automatically be assigned whenever they have a gamepad, but this effectively eliminates the ability to play on the same keyboard. So if you really want to have the same keyboard to be able to control 2 objects, you really need to set this up through the input, and have them work like that. So whatever it is you're working on, if it has local multiplayer, which it presumably does, like, I don't know, ping pong or whatever it is you're making, you simply need to create 2 control classes. Again, this is not the only way to do this. There's definitely many different ways you can perform this, but that's the general gist of things. Now, when it comes to collision, there's another set here that I kind of want to mention before we move on, mainly due to the reason that it's important to understand how collision works in Unreal. You see, right now I have this box over here. As you can tell, probably, this box is the root component, and the skeletal mesh is the child. Now, both collisions work, but the box itself, if I take a look at it, it simply stretches over the object. It does not, however, interfere with the actual gameplay. So if I don't, can I make the scale bigger? No, if I make the scale bigger, I'll also make my worm bigger, I believe. Let's make this 2. Yeah, those also increases the worm. So unfortunately, I haven't found a steady way of modifying. Oh, there we go. Box extend. There it is. Shape. So that's where I did this from. But the point is that this box only interacts with the floor itself. And if we take a look over here in the collision presets, you can see that it's currently on custom. And of course, currently it's collision enabled query and physics. Now, generally speaking, you do want that for my case, because I don't really need the physics, but the query itself might be required for raycasted sweeps, etc. For like if the player character is grounded, for example, that's how you would check. So query should be enabled in most cases. And notice that I have an object response here, a type of terrain, which is something that really is not part of the standard package. This means that you have to define it yourself in the project settings. So over here, if we take a look at collision or physics, there we go, physics, we should have, not constraints, look at the amount of simulation options you got, like loads. We've got different types of surface, which is just physical stats for it. I'm having trouble finding the actual collision layers, so I might have to actually search for them again. Let me just write down collision. Where is it? No, it's not that. Layers. Okay, this is weird now. It's somewhere here. I'm just not sure where exactly it was. Oh, there, it's in collision. Great. So yeah, you got different channels here, right? You got your trace channels and you got your object channels and the preset itself. Now, you will immediately recognize the presets here because they're directly mirrored across this, this kind of editor. So you've got the no collision, block hole, overlap, all these presets, as you can see, are available to you here. Right, vehicle, physics, active, destructible, blah, blah, blah. These are all defined over here, and they have their own sort of channel setups. As you can see, I've got my terrain, which the default response would be to block stuff. Okay, so whenever I define something as a terrain, it will block a bunch of stuff. You can also do the same as with trace channels. You can define your own little collision presets with all these settings already enabled. I simply wanted to do this a little bit more visually so that you understand what I'm talking about. And when it comes to overlap events, by the way, you need to have both targets to have overlap events enabled, such as this. In this case, you've got the general overlap events on this side, and of course, generate overlap events on this side. If I want to be querying stuff such as, you know, what did I just hit, or am I grounded, or etc., etc., etc. So I do need this to be working. And also notice that my terrain is blocking everything except itself. And the same goes for my worm, which is blocking most of this stuff. If I just go ahead and find my box over here, I'm blocking most of this stuff. I'm ignoring most of this stuff except the terrain, right? The box itself ignores a lot of these things. I think this is grayed out because I'm viewing it in the wrong spot. I'm basically doing a lot of stuff here. I really don't need visibility for traces and for the camera. I definitely don't need those, but you know, it's nice just to have them. And I ignore everything, right? Everything is set on ignore, so we don't really need that. And the terrain itself is set to block. So this will be blocked only by the terrain. The actual, like the ball itself will not interact with this. Nothing will interact with this. So I can set different, like let's say an invisible wall over here on each side. And this will allow me to effectively stop the player based on this box. And really nothing bad is going to happen because it will only work on the box. I'll have to, for example, set this up on the ball itself and tell it, yeah, we have to actually get blocked by the terrain, which is by default enabled since it's set to block all. Now, one final thing is that whenever you bring something in, I don't know if I kind of talked about this before, but the actual mesh itself does not come with collision. You need to generate collision on your own. Now, currently, I have generated a collision. Over here, as you can see, I've got some simple collision. Well, this isn't really that simple, but I generated it simply based off the actual mesh. But you could go for a lot more complex collisions such as this, where it just goes over every single face, right? That's pretty ridiculous. And like I said, you don't really need that. I could have just as easily worked with I could go to collision and simply create like a box collision and put this, geez, that's very fast. A box collision and just positioned it over here so that it kind of enveloped this, this terrain, this mesh. And again, we don't really need this mesh in particular. We could use any terrain. We could simply create our own terrain. And again, this is not ideal, but I simply wanted to create something different so that we could use that as a mesh. That being said, there really is nothing else I want to talk about in this particular video, since there really is nothing else to say when it comes to collision. You've got your three responses: the block, the overlap, and the ignore. Notice, by the way, that the overlap, you obviously need to overlap with something to generate an overlap event. But I do believe, yes, this is only happening for overlap. But I do believe you can generate, I think you can generate head events without having overlap over here. I'm pretty sure that's kind of the default behavior. And of course, they have their own materials, which we can, talk about creating at the end of this sort of game creation setup, since this is the tweak, that's basically the tweaking stage. All right. You also have some settings here, such as continuous continuous collision detection, which we will most likely end up using for our players, since we want very precise collision, at least as precise as possible. When it comes to the worm collision itself, by the way, you should note in the actual blueprint here that I'm getting all the classes and I'm caching them, but this doesn't have to be on event begin play. I can just as easily dump it into the construction script. And the construction script is basically being fired off whenever you either move something in the scene during editing time, or whenever the object is created. So I could just as easily put this over here, and whenever my worm controller gets created, which will get created the moment I start the game, this will fire off and will set my things. I just like to keep them here on begin play because I really don't intend to use begin play for anything else. So I kind of do my caching over here. And like I said, it's not necessary. You could just as easily go and just get player pawn, right? right and return this value and just dump it over here. But because we have 2 pawns and this does not really output an array, so unfortunately there's no way to work around this. It is of course possible, right? You can get the player pawns and cast 2, but I simply opted to get all actors a class and just work it this way. All right, that being said, guys, we will finish this video. I know it was a very short one, but I hope it's a breath of fresh air since my previous videos were probably a little bit too long. In the next video, we will actually start talking about the animation system, the whole entire really animation system. So that'll be a long one, right? So if you're kind of watching this on a binge, you better go and get yourself some, I don't know, some snacks or something. All right? Okay, cool. Save all, and I'll see you guys next time. Bye-bye.